Okay, so discontinuities. So a discontinuity is simply exactly the way it sounds. It is a place where the graph is not continuous. So the graph is not continuous at that point in the domain. There are 3 different types of discontinuities. The first discontinuity, I'm going to just zoom in, is where the graph approaches positive or negative infinity at some point in the domain. So let's go ahead and draw an example. We'll make our discontinuity occur at, we'll say it's occurring at x equals 3. So I'm going to say that x equals 3, so this is where 3 would be. I'm drawing in a dashed line, but this dashed line is not a part of the graph, okay? Dashed lines are not a part of the graph. That's called a vertical asymptote, and we're actually going to graph functions that have asymptotes starting in chapter 4. So what I'm going to do on either side of this asymptote is I'm going to create a function that is either increasing or decreasing at that asymptote. So here's an example. This is just an example. Don't draw it yet. This is an example of an infinite discontinuity. And what I want you to notice is that at this point in the graph, it's approaching this point, and the graph either is going to increase up or it increases down. So this is an example. It could either do that, or you can have it where they go up on both sides. So it could be an example where they both increase. So they don't have to go up and down. It can be an up, it could be a down, it could be an up, down, it could be a down, up. Like that is an example of an infinite discontinuity. So the main thing to keep in mind, and it's really hard to draw it, is that this graph is getting closer and closer to 3, but it is never going to be 3. So it could be 2.9999999, but it'll never be 3. Or it could be 3.0000005, but it'll never be 3. It's approaching 3. And the difference is getting so small that you really can't visually see it. So this is an example. So you can go ahead and create that, and then we'll move on to the next discontinuity. Okay, a jump is a sudden, I should probably say sudden change in the y value. And it's really like 2 different functions happening. And that's actually called a piecewise function. So we're going to graph that. So this time we'll say it occurs at x equals 0. So at x equals 0, I'm going to draw a function that stops at x equals 0, and then it's going to jump, and I'll have a completely different function. So it's 2 completely different functions. There's a sudden change in the y value. See how we were just, if we look at it, if you're, imagine you're walking on this graph, I have to jump to get to the next graph. It's disconnected.
So because they're 2 different functions? one circle is colored?
Okay, so the definition, that's a good question. I was actually getting there next. The definition of a function is that x cannot have more than one y value. So you cannot have two closed points. You can have two open points, but you cannot have two closed points because that would mean that x has a value of two different y values, and that's not a function. And the last one is a removable, which I think is the easiest because that just appears to be a hole in the graph. Okay, so I'm going to draw a horizontal line. And if I draw a horizontal line, and at some point in that line, I put an open hole and I continue. That's an example, okay? So in this example, this is the only discontinuity where the graph appears to meet up. Now in that hole, we're saying that right here, x is invalid. Sometimes you can have a closed point at a different place, but that's optional. Sometimes x equals whatever that is. Let's say that's at x equals 1. Sometimes x equals 1 just doesn't have a value. It doesn't have to have a closed point. So now that we have went through the 3 different types of discontinuities, let's identify them. We're going to figure out where they occur and what type it is. So let's look at these 6 graphs below and identify the different types of discontinuities that we see.
Why is for the removable, the closed circle doesn't have 2 rows pointing up?
So if we do that, let's talk about that. If I make this a graph, does that pass the function test, the vertical line test? No. The key is that these are all functions. So it has to still be a function. Whatever you create has to be a function.
Closed circle's not a hole, right?
A closed circle is not a hole. So at this point, we're saying that if this was x equals 1, oops, hold on, screen, okay. If this is x equals 1, I'm saying that at x equals 1, y is whatever this point is. All right, so now let's go ahead and look through these graphs. So let's look at A. What kind of discontinuity would you say we have here? It's a removable. Good. This is a hole in the graph, so this is a removable. And it occurs at x equals 2. So we have a removable at x equals 2.
It's not an ordered pair.
So it's only the point in our domain. It's all about the domain. Where in my domain do I have that discontinuity? So at x equals 2, we have a hole. All right, what kind of discontinuity do you think you see at B, in B?
Jump.
That's a jump, good. And where does that occur at x equals what?
0.
Good. At x equals 0, we have a jump. All right, let's look at C. What do we have there? Infinite. So on the left, it's approaching negative infinity. On the right, positive infinity. So we have an infinite at x equals 2. Now, when we look at the last 3, there's multiple discontinuities, okay? You can have a graph that has 5 different discontinuities at different places in the domain. So let's look at graph D. When I zoom in to graph D, I see that we have 3 different discontinuities. So my first discontinuity I see is at x equals -4. What kind of discontinuity do we have at x equals -4? Infinite, good. And then I see another one. Where's my next one at? X equals -1, good. At x equals -1, what kind of discontinuity do we have? A removable or a whole. And then I have my third one at x equals 2. And that one is a jump. And notice that at this jump, they were both open. So when you have a jump, one of them does not have to be closed. You can have at x equals 2, why we don't have, there is no x equals 2 in this graph. X just can't equal 2. For whatever reason, 2 is just not, it's not working. So both of these points are undefined. So you can have 2 open circles. You can't have 2 closed circles, but you can have 2 open circles.
So they would be undefined and not at the jump.
So there's a jump at x equals 2, and at x equals 2, y is just undefined. X is undefined. There is no y value. But we'll talk about that more later. The main thing I want you to focus on right now is what is the discontinuity and where it occurs. All right, let's look at E. In graph E, I see 1, 2, 3, 4 discontinuities. I see 2 removables, 1 jump, and 1 infinite. So I have an infinite at x equals 0. I have a removable at x equals 2, and where else? X equals what else? And at x equals 6. And I have a jump at x equals 4.
Why is the infinite at x equals 0 not x equals -2? Is that not?
So at x equals 0, if we look here, if I draw a vertical line.
Oh, so the other one down there, like in the bottom.
That's just showing, it's just, the graph is short, but it's showing that it's just going to keep going down. It just doesn't have the arrow, but it continues to go down. All right, and then F, let me zoom in on F. We have 1, 2, 3, 4. Whenever you see the graph appear to do like up and down, so right here, and again, we can draw in the dashed line here. At that point, there's an infinite. So we have, in this graph, we have a jump at x equals -2. Oh, we have 2 removables. We have a removable at x equals 1 and x equals... No, it's the x value. So this is a removable right here, and this is a removable right here. So what does x equal right here? 8. So we have a removable at x equals 1, and we have another removable at x equals 8. And then we have an infinite. And that is at x equals 2.
So you can't have two discontinuities with the same value?
No. So at that point, you cannot have, you can't have a jump and an infinite at the same point. And we are going to actually get into graphing discontinuities. Well, we're going to graph jumps, and then infinites we'll graph in chapter 4, and removables in chapter 4. So now it's time for you to create. So I'm going to come around and I'm going to check, but I want you to draw me an infinite discontinuity. I suggest you use a pencil. And a removable. So I want you to draw an example of an infinite discontinuity at x equals 2 and a removable at x equals 3. And I'm just going to quickly come by and see what you create and tell you if it would pass the vibe check on the quiz next week test. So go ahead and draw A and B, and then I'll come around. I do have some pencils up there. So like a little blue basket. And you can more than welcome to take a pencil if you need to borrow. You don't have to use a pencil, but I was just suggesting it unless you know you're going to graph it right. Confidence, you know. There's more than one way to draw the graph. So your graph does not have to look like your neighbor's, and you can both be correct. So right now, I just want you to do A and B. So go around and see what you got. Oh, this should be on this graph. Okay, let's go ahead and go through them together real quick. That wasn't bad for your first attempt at it. So at x equals 2, I'm going to draw a dashed line. This is optional. This is not a part of the graph. And then I'm going to make a function that goes up. Now, some of you all kind of made it look like this, which is technically not okay, but I would mark it right because you don't know better. But as long as one side increases and one side decreases at that asymptote, that's okay. But what it should be kind of level. Like that, but at this point you all don't know that, so I would take that. That's just an example. You could also have it where they were both going up. You could also have them both going down. If you want to hold it up, I can look at it from here. That looks good.
So we have to have two? I thought it was just one.
You have to have two on both sides of that asymptote. And then for removable, I usually just put an open circle where somewhere along x equals 3. We don't know the y value. The y value is not important. So you can put it at x, you can put it at 3, 0, 3, -3, 3, +5. But at some point along 3, I'm going to put an open circle. And then I'm just going to draw a graph. So I usually always default to a parabola. I don't know why. And you don't have to define 3. So you don't have to put a close point. You can just have an open point, and that's good enough. All right, turn it over, C and D. Take 30 seconds, draw me a jump at -4 and an infinite at -5. Whatever you draw has to pass the function test. So if I can draw a vertical line and it cross your graph more than once, it is not a function. So your jump, you need to have something else occur and go to the other direction. So you see if I draw a vertical line right here, how it crosses twice. One of these needs to swing to the left. They both can't swing to the right. So if I draw a vertical line, that doesn't pass the vertical line test. This is not enough. We need to have something else happening here that goes to the left. This is an infinite, looks like. All right, I'm gonna go ahead and talk through this real quick. So for your jump at x equals -4, it's really common. I saw a lot of people put your open and your closed circle, okay? And then you made them both go the same direction. Like, that's not a function. Because if I can draw a vertical line and it crosses it more than one time, it failed the function test. Everything you create has to be a function. So one arrow has to swing left while the other arrow swings right. And it really doesn't matter what it does. It could be a straight line. It could be a parabola. Yes, sure. So that would be an example. I usually make it pretty simple and I just do straight lines. You can't do a vertical line though. The pass is on the side of my desk. Why can't you do a vertical line? Because a vertical line is not a function. It has to be horizontal. So you can just do a horizontal line like that. You can make 2 horizontal lines. That would be a jump. For your infinite at -5, so I'm just going to have one side go up. I'm going to make them both go up, actually. And that would be your infinite. That's just an example. All right, E and F. Go ahead and do E and F.
So for the jump, I can have 2 open circles, right?
You can have 2 open. You cannot have 2 closed. All right, go ahead and look at E and F. Draw a jump at 2 and a removable at -2.
So they should both meet up. Wow. So this one is the scoop over. Oh, yeah. No, this is a. Did she show the grade of this? Is that why her name was on her jump? So now you gotta make something with this here. If you have a point, you have to do something. I don't know. That was probably. I know. Maybe it is right. No, yeah, you're probably good. That looks good. And then here, go ahead and jump up and make another line that swings to the left. So that's what I was gonna ask. You put it on the Y. That looks good. Yeah. Looks good. Looks good.
So, will the test be over what was over the quiz?
Yes.
And also this?
Okay. So let's go ahead and talk about these two. So we have a jump at 2. So I'm gonna put 2 open circles this time. I'm gonna put an open and another open. And I'm just gonna make it simple. Why make it complicated? A line going to the left, a line going to the right, done. It doesn't matter which one goes to the left and which one goes to the right, but they can't go in the same direction. And they have to meet up at the fence. So you can't have them both, like, yes.
Does one of them have to be a dotted line? Or
Open, a closed point?
Yeah.
No, you can have 2 open points or an open and a close.
Okay.
You can have one close. And then for your removable at -2, again, I'm just gonna make it simple and just draw a line. Horizontal line. All right, our last 2, this is where it gets a little tricky because you have to draw 2 different discontinuities and it has to be a function. So I'm gonna actually talk you through G. What I recommend you do is draw your infinite first. Just draw your infinite, ignore the fact that there is a removable, and then put a hole in the graph at -3. So draw your infinite at x = 4. and then go back and put the hole in.
Miss Brent, do you know the song Back on 74?
No, I don't know that song.
It's a great song.
The infinite should be an x equals positive 4, which is over here. Yeah. We got a lot of arrows happening here. So we don't need all the arrows. So you can't draw two different graphs. It has to be one connected graph. So you need to maybe connect this two. Yeah.
So you want to get this one?
Mm-hmm, right. So you kind of did the same thing. You have two separate graphs. That's not a function. So your primary should be your infinite. So just connect, draw that out, erase that. Draw that other one all the way to the left and put a hole in it. Okay. Sorry, I'm running out of time.
So for your infinite at 4, I'm going to draw my infinite at 4. So at 4, I'm just ignoring the fact that there is a removable right now. Just like that. Then I'm going to put a hole at -3. That would be, that's it. Yeah, that's it. That would be my graph. And really, I should try to erase it. Let me erase it. But when I erase it, it takes the whole thing away, but that's okay. So I'm just going to put an open circle here and redraw it like that. For H, draw your infinite. So I'm just going to ignore the jump. Draw my infinite at -3. So everybody draw your infinite at -3. That's why I said use a pencil. So I drew my infinite, and now I need to erase it, starting at x equals 2. So I'm going to have my infinite continue. It's going to stop at x equals 2. I'm going to put an open circle. And then I'm going to jump up or jump down and create some totally different function. So I'm going to jump up and just make a line. That would be, these are examples of what a graph would be. On the test, your test is going to cover everything that was on the quiz, and then we're adding on graphs. Okay. So I did grade the test. It is entered into Skyward. The deadline to retake that is September 22nd. So use this time now